We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporlan's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporlan.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporlan signing off.
All right, just so I don't screw this up right away. Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel, Kevin Compass, and Damon Reed. Damon
Hey,
Reed.
guys. Hey, everybody.
From Pro Refrigeration. How you doing, buddy?
Good.
So we have a guest on tonight. Damon specializes in like really cool fucking chillers, like just different stuff that they use. It's kind of crazy. So we're just gonna start talking and see where this conversation goes. Real, just because this is just the norm. How's your week going, buddy?
Oh, my week's going great. I'm in North Carolina.
Why?
Well, our manufacturing plant's here. We've got a 60,000 square foot facility just north of Charlotte and south of Raleigh, right in between. But the beauty of the weather here right now is it's 72 degrees, sunny, and the humidity hasn't kicked up just yet. So it's gorgeous right now. I've got some guys back on the West Coast that work out of our Auburn, Washington headquarters. Mm-hmm. And they're still talking about being a little north of Seattle and dealing with snow right now. So I'll take 75 and low humidity every day of the week.
That's funny. I was just out in California last week and like everyone was freaking out because they're like, there's going to be snow on the Hollywood sign. I'm like, really? And then our James Coleman, he's a startup guy out here and he lives out in the high desert and he took a picture, took a video and was like, oh my God, it's snowing in the fucking desert. That's insane.
That's wild. That was really wild. Yeah. Yeah.
Kev, how you doing? You
It's
said
been a-
you said before you were dead inside. What happened?
well, I started out Monday morning with my van breaking down halfway on the way to work,
Mhm.
and then driving back home Monday afternoon with only being able to go like 50 on the highway.
Sweet. So what'd you do?
Then I spent last night ripping the whole top of the motor apart in the van to change coil packs.
That's called calling in sick the next day. That's what that's called.
Well, it's called. I live an hour and a half from the shop, and to get a van dropped off would be a nightmare. So get stuck fixing it myself.
Oh, and then what happened? You sent me a picture. What was that? I couldn't really tell what that picture was.
Which picture?
It looked like you were taking a picture of a key or something.
Oh, then the key snapped off in the ignition.
Is that like it? Like, was it so cold in Indiana where
No,
like it just?
it's literally like I went to go turn the key after I fixed it, and the transit key snapped off in the ignition. So currently, my van starts with a knife.
Oh man.
Working in the hood every day. The key's literally jammed in the ignition. That's literally how my Monday went.
Ugh.
And then this morning I was switching over lighting contactors in a 40-year-old grocery store almost, and went to go turn the two lighting contactors that haven't moved in probably 15 years. They didn't sound so well. Then half the case fans went off, so I just gave up at that point.
Wait, how does the lighting contactor pull in and then the fans shut off? What happened?
They evidently, in the last 20 years of remodel upon store changeover, they decided that they're going to put fans in the lighting contactor panels. So, yeah, that was my day. After I look out there and I'm like, half the lights are still on. All the cases are getting warm. Okay, I give up.
So today's only Tuesday. So how did Tuesday go?
Was it fixing lights?
No, I gave up at that point because that's out of my scope. And then today we were mounting VFDs in impossible spots.
Well, just use some Unistrut and get creative.
Oh yeah, that's what I did. I've been building Unistrut stands all day and putting VFDs inside of blower cabinets because there's nowhere else to put them.
Fun times.
Nice.
Yeah, it's been a rough week already. So hopefully the rest of the week is good. Oh, and I flooded an entire 3 aisles of a Walmart like at 4:00 today.
What the fuck? What happened?
I went to go help an apprentice, and we started de-icing a case, and all the floor drains started backing up from all 3 aisles.
Ooh.
Well, that wasn't like totally your fault. I mean, the floor drain, that's a plumbing issue. That's not it.
It was bad. I turned around and went,
That's why Kevin's dead inside. So Damon, what are we going to talk about tonight, man?
So I think we're going to talk about some chiller systems, packaged industrial process chiller systems. I've got some stuff to talk about. We can kind of look at some presentations, but one of the neat things we had was a couple of years ago, our company CEO, Jim Vandergeesen Jr., he brought an initiative out that we were going to design a transcritical CO2 chiller system, all air cooled.
So is this 90 bar or is this 140 bar?
I'm designed for my high sides at 120 bar and my low sides 90 bar. So I'm a high standstill pressure.
So you can basically shut that shit down and it won't pop off.
That's right. That's right. And I mean, we built, so, I mean, we tackled it. We worked with some companies, an engineering company out of South Africa when we designed the system and did the initial layout. And then it was my job with my team to put all the pieces together and then make it work. We fired our first system up, put it in Bakersfield, California on a dairy farm. So we're cooling raw milk. The chiller systems, of course, it's all, when I say it's all packaged, I mean, I've got all the pumps, the reservoir, so the refrigeration rack, and I'll explain the kind of the details of it when I call it the rack side. Maybe a lot of people on this call will understand already what I mean, but what we're doing is we're cooling, our evaporator's cooling a 750 gallon reservoir of propylene glycol, and we're holding that at 33 degree Fahrenheit set point. And then we're pumping that to a plate and frame heat exchanger inside the facility. And then I've got just a steady, constant flow of raw milk coming in at 98 degrees Fahrenheit. and I'm taking it down to 36 degrees Fahrenheit and storing it in bulk storage silos. So if the chiller hiccups and things don't work, that ain't good. It's that one pass and the milk flow doesn't stop. So hot milk is bad. And we've maintained the system that, like I say, that one's been going now for just a little over a year, maybe a year and a half. And the results have been stellar. We fired up another unit since up in Talkeetna, Alaska, at a distillery. And then we also got our third unit in operation. It's at another dairy farm down in Bakersfield. And I've got 2 more on the ground ready to get commissioned on site. One's kind of a unique hybrid where we have one side of the system is 150 horsepower of 448. And then I've got my 100 horsepower rack CO2 chiller system on the other side of the unit. So
are these units all HPX copper? Are they all stainless?
They're XHP. So we're running the high pressure copper on the systems. All the valves, most of the valves and components on everything are 140 bar rated. And then on all the coppers, it's XHP 130 on everything. And we went through that transition where it was the changeover from where you had Wayland switching over with Mueller, and so you had K65, and then you had XHP 130, and at the end of the day, it's all the copper iron is the material that we're using, and the high pressure rated stuff too.
So we met up with Damon over at AHR, and we were probably shooting the shit for a while. It was funny because like after we talked to you, we talked to Waynard, and he's like, "Yeah, I designed that system." Because I was like, we were just talking about it because we were like, "It's so fucking cool, like how this thing works." And he's like, "Yep, that was me." I'm like, "Oh, okay."
So yeah, Waynan, we worked a lot with Waynan. When we fired up, Sean, who's Waynan's partner, he came out and we he came out, I picked him up like up in Seattle, and we were driving down south to California. So we spent time on the road, and then we had a good 2 weeks on site with that first system operating it, getting everything charged up, working out just little controls bugs and where we needed things to operate to give us the performance that we were after. So it was a blast. Yeah, it was good times. I've become an expert at WhatsApp. So that's the way to communicate overseas and not have to pay a lot of fees on phone calls and such.
Wait a minute. I'll call Canada all the time, and I don't get any fees.
Go overseas. If you're talking with like Mexico, South America, Europe, Asia, WhatsApp is a really nice tool to use.
Oh, that's interesting. We tried to call for that rack at the Walgreens, and I was like, "Whoa, no charges here."
Yeah.
It was
WhatsApp.
My wife would have killed me.
Yeah, didn't you say it was over in Sweden? Did you ever see that manufacturer? Did he tell you the manufacturer? It's like, what the hell was it? Green Skill or something like that. Yeah, it was some Swedish monstrosity.
What was that you were working on?
It was a CO2 rack heat pump with full heat recovery. So nice. it was doing the cooling, the heating, and the refrigeration.
Oh, very cool. Very cool. Yeah.
It was just cut apart though. The refrigeration was really? Oh yeah. It was just basically all it was doing was heating the building at that point.
What? Oh, bummer. Yeah. So like our chillers where we tied in with our heat reclaim system. So I'm heating all the facilities hot water with the chiller system. Because imagine, so like with the heat pumps in a heat pump application where we're like generating hot water for, I don't know, an apartment complex or something, right? And maybe it's like an air source type scenario. They're looking to the air for that cooling load so they can get the heat, right? But the cooling, it was kind of a unique thing for me. Is like I'm all focused on the cooling, and I keep a real steady cooling load on the chiller system. It's just I've always got cooling load. So all of a sudden for me, the heat was kind of a scenario where what do I do with all this heat? And with CO2, what's really neat is you run the system transcritical and you run some higher discharge temperatures, so you can get really, really hot water. With something like 404A or 448, well, I'll get a little more with 448, but let's say 404, I'd be looking at temperatures of like maybe 130 to 140. I could get tops out of a heat reclaim system with a recirculated loop.
So I have a question about that then. So was it engineered from the get? Like, okay, let's just say you had 5 million BTUs that you knew of that you had to do cooling for, right?
Yeah.
Did they put in a specific system with essentially, obviously it's going to be a little bit more than 5 million, right? Because you have the latent heat and shit from the gas cooler and the sensible heat, the total heat. You always have more total heat of rejection than you do actual fucking cooling load, right?
That's right.
So my question is, were those heat reclaim tanks specifically engineered for that? Like, or because I'm confused, because like there's no way you could just be like, oh yeah, 5 million BTUs is going to be enough to heat that water. You know what I mean? Was it perfectly engineered for that, or was it just like they have like a backup just in case that can't make it up? Because like you said, you have a constant load all the time.
Yeah.
But like, what are the chances that you're going to have the exact amount of load that you need to heat the water and cool the freaking facility? That's where I'm kind of losing it.
Yeah. So storage reservoirs, and that's where you learn more. So initially, when we did the design and development, it was, what is our maximum heat recovery potential that we could get off of this piece of equipment?
Mhm.
So our refrigeration load in BTUs per hour was steady. I have a steady BTU per hour cooling load that this facility is going to be able to deliver.
Cows are always milking.
That's
Cows are
right.
always milking.
That's right. So I got steady BTUs per hour I'm working with. Now factoring in total heat of rejection, ambience, things like that. Now how you size up your heat exchangers and things for the heat recovery side, you have to identify on the hot side, you got to say, okay, what am I going to design for? When you got to pick a design point, you're not going to be spot on every single time. You kind of got to pick a big window, right?
Yeah, you got to do it by the amount of flow of water and how hot they actually need it. And fortunately, it's all a sensible load, because we don't want to turn that water into steam, right? So I mean,
that's right. And you can with CO2, and you can. And the controls on the system have boiling alarms. If the heat reclaim side starts to get too hot and it starts pushing up close to, I think it's around 205, it starts backing off the heat reclaim system. You're moving three-way valves. So we have a heat reclaim valve in the refrigerator. So we come off the discharge side, we come into a three-way valve, and the three-way valve is saying, okay, I'm either calling for heat recovery. So I'm going to push the discharge gas through my heat recovery heat exchanger and then up to my gas cooler, or I'm going to divert away from my heat recovery system and I'm going to just push everything through my gas cooler at that point.
Gotcha.
So are you using a modulating three-way valve and modulating it, or is it just open?
Yeah, it's 0 to 10. Yep, 0 to 10 actuator, and it does modulate, so I get the full range of it. Slow acting. It's like
control there.
Yeah. So on the control side, we're using the Danfoss controls. So it's just a rack control. I think you guys were talking about switching stores and stuff over, Kevin, I think, to like the 800, the system manager. So I use the 850A is what I'm using for my interface. That's my system manager. And then I've got a 100 horsepower parallel compression rack. And then I'm using the 781 to control my rack. And that's controlling my heat recovery. That's controlling my gas cooler fans. That's controlling my flash gas bypass valve, compressor VFDs. And then we're talking with a 750, which is so I've got a 781, 750 is controlling my evaporators. So the evaporators I just bring on and off based on the reservoir temperature. The reservoir temperature gets above set point, I go ahead, I bring on my 750. My evaporators start controlling, my EEVs start opening up, suction pressure comes up. So my medium temp suction temperature comes up, and then my compressor fires up and it tries to run. You guys are probably familiar where you'll run like neutral zone, plus zone, or minus zone to bring on your compressors. So at that point, it just kind of, everything just happens like, it's like magic.
So everything just turns into basically a normal parallel rack.
Exactly. Yep.
750s. I'm just getting into Danfoss to the point where like I'm getting heavy into it. So are you guys using case controllers for the 750 is a case controller, correct?
Exactly. Yep. It's a case controller. So case controllers is what's running my evaporator. Yep.
Okay, so the chiller is going to be your process variable. The fluid temperature is going to be what it's going off. Is it fluid temperature or is it going off sump temp?
So I'm going off of fluid temperature. So fluid temperature inside the reservoir. We run, so my 750, we program the 750 so it takes a signal from a pump. So if you, what you do is you add, like in the programming side, you add a calculation variable. And with the calculation variable for, like, you assign it to whatever IO you're working with, wherever you've addressed, we just run like a current sensor. And then I say, okay, if let's say, for example, reservoir temperature gets above, let's say I want to hold 33, I could set it and say hold right at 33 and shut off right at 33, and then it'll run PID calculations to give me a plus or negative output. But then it'll start the internal pump, and then as soon as that pump starts, you measure that current. We're just using a current transformer to send another signal to an input to the 750 that says, okay, I'm seeing input voltage here. Go ahead and start running my EEVs, and I run 2 dedicated evaporators.
So I got 2 questions now. I'm assuming you probably float the suction to basically maintain, if you don't need that full pull down and it's still maintaining glycol temperature, or for that you float that up. Yes.
No.
It's constant all the time.
Constant set point. So I set my suction temp at, let's say, if I'm looking for 33, let's say I'm running at 23. Maybe I'm giving myself a 10-degree delta there. So I just say, hey, suction group, I want you to maintain a 23-degree evaporator all the time.
Okay. And then the other question I had, which I think it's gone. I think it's gone.
Yeah. Well, now you run your EVs on, I just run my EVs as injection.
Pumps. So I have a question. So like us dealing with refrigeration, like we deal with, because our loads aren't constant, we have circuit setters on our heat exchangers to maintain a certain flow. The fact that I'm assuming your chiller is only going to one heat exchanger, your pipes are basically designed for your set amount of flow. Would that be a correct statement?
Correct.
And then you're still trying to maintain a TD across TP, Delta P across for your VFD, and that's what's sending back the signal. So like if it's just running, if the chillers are perfectly sized and the piping is perfectly sized, usually it's like a 0.5 or 0.2 differential across that heat exchanger or something like that.
Well, here's kind of, I think I know where you're going. So a lot of times when we're talking chillers in the world, we're talking single pump systems. So I'm running one pump that's feeding evaporators, and then it's coming back and it's feeding, let's say I'm doing glycol to air heat exchangers or something. I'm gonna feed my process loop, and I'm gonna feed the refrigeration or the DX evaporators with the same pump that's feeding my process loop.
So you're not just doing one heat exchanger, you're doing multiple.
Well, I'll do 2 evaporators. So on my refrigeration circuit, I've got my 2 brace plate. I run brace plate heat exchanger evaporators. I have one pump in the piping that's all sized to give me the exact flow that I'm designed for, and pressure drop on that evaporator. That's my internal circulation loop. Then I have a separate dedicated pump for the customer's process loop. So in this case, the customer's using the plate and frame heat exchanger. I've got that pump set aside, dedicated just for their process side.
See, that makes more sense because it's all internal. Like you guys are designing for just that heat exchanger and that load with that pump. So you better. Now, do you guys run primary, secondary? Like you got a backup?
I do have a backup, but I don't like lead lag. So I give the customer a manual control, and I'll explain why. So before we did it one time, we had like auto switchover and lead lag control on the backup. And what you'd find is it depends on the application. I mean, if you're dealing more with industrial refrigeration contractors, they're going to be a little more on top of stuff.
Never.
Depending on, yeah. When I'm working on other applications, a lot of times what could happen is the system will automatically switch over to backup. Let's say the primary has a failure. Nobody pays attention to it. And then they don't pay it because their product's still cold. The system's still working. And then they come out and they go, oh no, My backup just failed because whatever took out the primary pump didn't get corrected. So now it took out the second one. And now they come out to it. Now the system's down. Now it's an emergency. And your end user will have the comment of like, I paid for a backup pump. How come I'm dealing with this emergency when I got a backup pump? So by going to a manual switchover to go to the backup pump, that gives us that physical check. Like somebody has to go out and switch a switch to run on backup. Then they have to address what's going on with the primary.
You get a really loud siren, really loud siren.
Yeah, lights.
Flashy lights.
Stuff can be ignored
or taped over.
Yeah.
Oh yeah, right. Taped over. I replaced a lot of taped over door alarms yesterday.
Oh yeah.
The bakery woman was quite pissed at me.
I can imagine so.
She's the one that broke your fucking truck. You know that, right?
Probably. She's looking very rough, so she may have broken my truck.
That's awful. Grandma's looking rough. She's got some city miles. She sounds like she's 4 cartons of Newports in. I just need one more nickel on this nickel slot, and I'm gonna do it.
This will be the one pull.
So back to the chiller, because I mean, because like I said, I fortunately enough, I've been able to, I've done process cooling and rack refrigeration type chiller stuff. And that's like one of the biggest changes because our loads change so frequently. Cases maintain temperature. So the piping is designed for roughly what it should be for like the mass amount of GPM, but we still need to make sure we have the proper amount of GPM going across those heat exchangers. Because as anyone knows, if your approach is off, you're not going to pick up or you're not going to reject the proper amount of heat, and your heat exchangers aren't going to work worth a shit.
Or you could take too much, right? You could take way too much.
The next question, from looking at your guys' chiller, it looks like it's an open loop.
Yeah, correct. Not a pressurized system. We're vented to atmosphere with our reservoir. Yep.
What's the benefit of that? Just so you basically have a little bit of a stowage?
Yeah, well, being an open system versus a pressurized system, I mean, so with an open system, you don't have to deal with like on your glycol circuit, everything like that can build pressure on the glycol side has the ability, it's just going to vent to atmosphere. So the reservoir itself has vents. They're sealed, so you're not getting debris and stuff inside, but any built up pressure in the system is going to vent to atmosphere. So I'm not really big on like HVAC hydronics and stuff like that. So I can't really talk a lot about what advantages of a pressurized loop would be versus a non-pressurized. I just know that our systems are, when I see them installed, the piping loops are pretty simple compared to some of the stuff where I go into some pressurized loop systems and there's a lot of tanks and a lot of actuation, a lot of pressure bypass and things like that we don't need to, I usually don't see that on an open loop system.
Oh yeah, an open loop system's a lot easier. I mean, just in general, it seems like instead of having to deal with a little bit of pressure loss or air getting bound up in there.
That's about the only headaches you kind of run into on that from a fluid flow standpoint.
So how many pounds of CO2 are you guys averaging in these chillers?
Say that, come again. I'm sorry.
How many pounds of CO2 are you guys averaging in these chillers?
We're holding around 450 pounds for an operating charge.
It's actually quite a lot.
Yeah.
That's actually about what an Aldi runs, a little bit more.
Okay.
But how many BTUs are you doing on these chillers typically?
I'm doing close to around 700,000 BTUs per hour.
So he's like a two racks on a super target.
Yeah,
usually they're like 350, 400,000 BTUs per rack.
Does that?
That's a lot.
Yeah. Compressors. What do you put in there?
Well, we're running on our compressors. We're running 2 50 horsepower bits or compressors. So I got 100 horsepower a compressor on the system.
Did you check out Copeland's new centrifugal CO2 compressor they got?
I have not.
I think you need to check that out. It looks pretty nitty.
Gotcha. Yeah. Most definitely, man. Most definitely.
So, do you have any pictures or anything that you could share with us so we can
Why don't I
scope this
show you
out?
guys? Why don't I start? Let me just show you I'll do a share screen and bear with me here. So I'll share a PowerPoint of a presentation we had put together that had shown the system that we fired up in Talkeetna, Alaska. And
What's up with having a distillery in Alaska?
so Denali Brewing has got a brewery there, and then they're doing a bunch of it's canned cocktails. So they're using their distillery to make canned cocktails, and a lot of the stuff goes in for the Seattle Kraken to that arena. So they provide all those drinks for those guys, and so we're this CO2 chiller system's dedicated to that production line for them.
Just keeping Seattle drunk. That's good.
Bring it. Yep. So this is. Are you guys able to see this? Is this sharing okay?
It's coming up. It's doing something. Click over on the Danfoss tab if that's the one you're trying to share.
No.
It's not doing it. Why is it not doing it?
Weird. Okay, it should be running the PowerPoint. Boy, it's not liking that, guys.
Oh, that's freaky.
I'll stop sharing then.
Like it's my computer doing it.
Here, try it one more time. Hit present.
Here it comes.
And then you got it.
Yep. See if I do this window, if that works better.
There we go.
All right.
Try to get the most maximum.
How's
there
that?
You go. That's perfect.
There we go.
Here, I'll get rid of our fat faces.
So this gives us, this is the overview of the system. So parallel 50 horse. This package represents the exterior. This is the whole circuit. 750 gallon reservoir that sits back here in this area. Onboard heat recovery. We're generating up to 180 degree water. That's coming in at 70, coming out at 180.
Damn.
Jesus, quite the pickup.
Yeah, it's huge. And we went E-rated fan motors, so we're basically variable speed drives on our fan motors. We're running process pumps. Everything's got variable speed drives, standby backup pumps, all stainless steel. The interface is panel touchscreen. That's the 850. And then we've got our cold chain verification, which is a online, so it's like a cloud-based industrial IoT monitor system.
Does that mean that this system runs subcritical, like probably most of the time?
Well, it depends. So I can be subcritical, but if I'm looking for heat recovery, then I'm going to force the system to run transcritical at that point.
Okay.
Yeah, you get way more heat out of it that way.
That's right. So if I go into, and maybe I'll show you, and I'll share this. See if I can get this. So is this Danfoss view coming up right now?
No, it's being lame.
Okay. Let me show you guys this. This is a system that's running live. It's kind of neat.
I'll blame it on Kevin's internet.
Bringing it.
I kicked the kids off.
Stop playing Fortnite.
Maybe I got to go blast mine. They're playing the Oculus now. You guys get into that?
One's on the Oculus, one's on the Xbox. I have to shut the router off when I go to do this.
I can't do that. Mine will freak out.
Don't freak out. My 12-year-old's figured out how to get into the router though, which is a problem.
Oh, that is a problem. So right at the moment, are you guys? Is it showing the?
Yeah.
The site? So this system let's see, back in California right now, it's 6 p.m. So they might have already cycled off with their operating load. But this gives just an overview of the system, where kind of a simple look. And then I've got, so this is my rack control on my compressors, gas cooler, high pressure valve, flash tank, flash gas valve. And I can see my suction group and get a peek at my evaporators.
So are you guys using like CCMT valves for
yes,
EVs too?
Yep, sure am. Yep. So we're CCMTs, and then the high pressure valves is CCM valve.
Okay.
Yeah, this one's sitting idle right at the moment.
She off. Tell him to start pumping out some milk.
Come on.
I've
Yeah.
never seen anybody use the graphics in Danfoss.
Say that again, Kevin.
I've never actually seen the graphics get used in the 850 or the
Oh,
88.
awesome, man. It's awesome. And setting it up, like, so you could go in through that and you can grab like any of your control points that are built into the system when you're running it. And like one thing like you don't see on here is you don't see suction superheat, right? You could do the calculation manually, but as a technician, I want to walk up to that 850, go to my site views, and it would just be nice to have a really quick snapshot and where you can see all this visually. And so I think on one of the updates I did on one of them, I put the suction superheat right here between the two compressors, just so that if someone's doing some service work and we're having to do some support remotely, we can provide that for them.
No, I think the graphics are like with CO2, the graphics are like 100% necessary, because especially with like guys trying to troubleshoot it, like having the graphic there with like all the pressures and temperatures, it makes life so much easier. And arrows with which way everything goes. I mean, just following from a technician standpoint or an apprentice trying to walk them through it, like it is like a huge time saver.
Oh yeah. Yeah. Well, I've seen stuff where like, say for example, like coming out here, this is like 300 PSI up here on my gas cooler, high pressure valves at 0. Let's say I'm at 300 PSI in my flash tank, flash gas valves at 0%, right? And then maybe my suction groups are sitting all idle. We saw that when we got into some really extreme, we were like -40, -35 ambience up in Alaska, where the system just sits idle, so there's some things that we learned through this winter to overcome that.
She needs a bump. She needs a bump for a minute on a compressor, and then she'll take off.
Yeah. There's some, and you can do some unique things with some new valves and that stuff that we're still kind of working that magic. But at the end of the day, it's just like what you said, being able to see it on the graphical representation it was huge to be able to look at it and say, okay, well, this isn't making sense. Like right now, I run my flash tank at 500 PSI, or 550 is my set point. Mm-hmm. So I expect to see my flash gas valve opening just a little bit. And as this is running up, of course, nothing's moving, right? So my high pressure valve's at 0. So this pressure really is just going to kind of sit idle. And I've got 400 PSI over here on my suction group. And I think it's like, I want to say it's like 450 PSI is where it'll cut in. So even if this pressure does come up and we don't have any cooling demand, let's say our evaporators are at 0% on our EEVs, all it's doing is just doing a quick pump down cycle, so it might come on.
In a place like Alaska, at one point, like when do you just bypass the rack, hook up a dry cooler to whatever process shit you're trying to cool, and just run a basic dry cooler for refrigeration?
Absolutely. And we built some of the systems that we built for them that were on the synthetic side. We did that. It was
get the hell out.
You just run a dry cooler on your return line, but then you gotta, that fluid that's coming back, you gotta watch if the flow shuts off, how does that drain back into the reservoir? And so it's just, nothing's ever as easy as it sounds. It's kind of what you learn.
Well, yeah, because you're obviously not running glycol down to a -40 freeze point. So, because that would take a lot of horsepower on pumps and everything else. So, you could still technically freeze in the dry cooler.
That's right. And I've seen that. Like up in Maine, where a dry cooler, the flow stops and maybe they're freeze protected to like -20 on their glycol, and they deal with -30 ambient, and they come into some busted pipes.
We had that at a store up here, an HE store, that the whole store uses a bunch of Reacold towers for glycol loop, and everything's water cool. Well, they had a power outage and it was -20 for like 2 days, and all the towers froze.
Oh man, that wouldn't be fun.
Tarping it, and we were up there with tarps and the turbo heaters for like 6 hours to try to get one to thaw. And then all of a sudden it started raining glycol.
Oh shit!
Did like the whole, like where all the fill material is and everything, did that all freeze up, or was it like the basin that froze? Or
solid? It was the the whole tower was just a bricked up mess.
Ugh.
It looked like Elsa fucked that thing up.
Oh yeah, it was just glycol, and then all of a sudden it was like, oh, we got flow. All of a sudden you just hear the apprentice go, it's coming out the drain. I'm like, oh, it's just pure red. It's like, oh well, that tower's shot.
Oh no. Yeah, no. Yeah. We did. Our learning lesson with the cold ambience was, and I mean, that's a lot of credit to Danfoss for having the controls are basically already pre-configured. But in the low ambient, you just bypass your gas cooler. Just don't run any gas up to your gas cooler, and you control everything based off your gas outlet temperature.
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
That's new that I think we're going to start seeing a lot is because we're having a lot of load issues at like smaller stores like Aldi's and like small stores like that. I mean, when they had nighttime, when they put all the nightshades on the cases, they have no load. So that gas cooler just eats up all the CO2, and it just when the fan comes on, it's just very poor load control because of the way they're doing the fan staging. They stand 4 fans on at once, and that droplet temp instantly just drops, and it just hunts.
Yeah,
and then it causes pressure.
Everything just
freak out.
Set stagnant. That's one thing I know with CO2 is you start paying closer attention to those pressure differentials. Because you'll see everything just go flat at one pressure. It may be 400 psi, but it's 400 psi everywhere. So you're like, okay, well, doesn't matter if I open valves manually. It's 400 psi on this side of the valve. It's 400 psi on this side of the valve.
Nothing ain't going anywhere.
It ain't going nowhere. Yeah.
So one thing we didn't talk about.
We've had a couple of stories.
Sorry. Go ahead.
So we've had a couple stories where they went down where it's like it was real cold that they wouldn't start back up until you bumped them. Until you bumped held a compressor contactor in for like a minute, let it build up some pressure before it would actually just moving again. It just wants to sit on the roof, like a normal refrigerant would, but like it seems to be a little bit worse.
Yep.
So what I was going to say, one thing we didn't talk about first off the bat, I know Pro Refrigeration does a lot of specialty stuff. I want to hear about some of the other stuff that you guys do and where you guys are located and how far y'all range.
Yeah, so the company was started a little over 30 years. I want to say 33 years ago. It was started by Jim Vandergeesen Jr., Jim Vandergeesen Sr. They started building a chiller system to work for the dairy industry, on-farm raw milk cooling. And they came from a background of family history in the dairy industry, but then they were also both worked in the putting in food processing plants. So kind of took refrigeration background and fabrication and system design background and developed a chiller system. Over the years, we do a lot in the micro brewing world. We do a lot in wineries, distilleries, bakeries, pretty much anywhere you're going to encounter food processing. You're usually going to find a glycol chiller system somewhere in that facility. About 5 years ago, we developed a system that operates at negative 45 degrees Fahrenheit, kind of geared towards the oil extraction markets. And that's our M45 series. So we kind of have our standard product range, which hits a sweet spot anywhere from negative or plus 5 Fahrenheit to plus 45 degrees Fahrenheit for an operating set point. And those are built from 3/4 horsepower all the way up to 260 horsepower on a single skid. And then then we get into our M5 series package, which runs from +5 to -20. That's using a single stage refrigeration compressor. And then we go into our M45 series, which is where we're using a compound compressor system. And then we also have built some, we have a custom manufacturing line where we build some custom rack systems for some customers.
So because of the PT
Really?
chart, sorry.
So you guys built racks too, like normal refrigeration racks?
Yeah, but
Really?
only like custom industrial type applications. So not supermarket or C-store type applications. Meat processing plants, smokehouses, some of those types of applications.
So the -50 stuff you were talking about, obviously it's fairly easy to do that with CO2, is just dropping the suction pressure. Is that what you're doing, or are you using like a regular HFC or HFO for that?
That I'm using just a regular, I'm using 404A on that.
Really?
Yep, minus 58 degree evaporator temperature on that.
See, but with CO2 though, Brett, you'd be getting real close to the to it breaking up from dry ice.
Yeah, you don't want to. You don't want to go down below 100 psi in your system. You start tickling that on CO2, you'll start hitting those critical points. It's also it's something to consider. What Pro's doing with the CO2 package is we only build one model right now, and that's the 100 horsepower. So the M45 series, the low temperature systems, those are hitting a range of operating capacities. I've got a 15 horsepower, 20 horsepower, and a 25 horsepower size. And so they're compact, 4 foot by 8 foot. Everything's packed into a real small space, small area. And then heat transfer fluid is different. Yeah.
What heat transfer are you doing with that -45? Is it cooling a fluid, or is it cooling air?
It's cooling a fluid, and we're using a Dinylene HC50, which is a potassium formate. Your glycol, when you start trying to run propylene glycol, you start getting down below -35 degrees. Your glycol just, when things get cold like that, you kind of run into density of the fluid really has a big impact. So, and viscosities change a lot along with that. So propylene glycol just kind of sits stagnant in your reservoir. Your pump's pumping, but it ain't moving. You would almost have to go to like a positive displacement style type pump, as opposed to a centrifugal pump to get that stuff moving. So it makes sense to go with a different heat transfer fluid, which is a Dinylene HC50, which has a better viscosity at a lower temperature range.
Have you guys done the ice rinks yet?
We have not done any ice rinks. No, we've been approached a few times. We've looked at the applications a little bit outside the wheelhouse on stuff, and we got our hands full with everything that's in front of us right now.
Yeah, I would love to see one of those CO2 chillers on an ice rink. That thing would probably kick ass.
Yeah, that'd be a trip. Yeah,
well, you could use the heat for the heat recovery for the rink, as far as on the air handlers, to keep a constant load on the air conditioner so it doesn't get all humid and dumb in the place.
Yeah, I mean, anywhere there's opportunity for utilizing hot water with a CO2 system with our heat recovery. I mean, it's just like it's just you're just helping out the refrigeration circuit and taking advantage of all that waste heat that you could generate.
Well, yeah, I mean, and you're at the same time you're lessening your transcritical time too. I mean, with you're forcing it into transcritical, but you're also lessening that when it doesn't need to be transcritical by using that heat reclaim, because it's picking up that extra heat and desuperheating it. So I mean, that's a huge. You could also use heat reclaim for mitigating your transcritical time. But you guys are probably running transcritical most of the time, correct?
That's correct. We actually, so when I switch over and I go to and so if you look at on the hot water system, you have swing tanks or buffer reservoir tanks, right? And where you monitor the temperature to control your heat reclaim is you monitor those tanks. And if that tank temperature gets below set point and your refrigeration's running, well, then you want to be in heat reclaim mode. And so if everything downstream is sized correctly, then technically, if you get perfect, your load on your refrigeration is running heat. You're recovering all the heat you're wasting. So now your gas coolers are hardly doing anything. And so you're just maybe sucking a little bit of the edge off of that temperature just to get your gas outlet temperature down. But when we go into that heat reclaim mode, we shift the heat reclaim valve to run heat recovery, but then we also run our gas cooler. We run our high pressure valve to a higher set point. And so we'll say, hey, we want to run to 1200. I may want to run to 1350 for my discharge pressure.
So can your guys' heat reclaim coils can under normal conditions, can they take enough heat out of there to actually condense the CO2 and bypass the gas cooler in the middle of summer, or is it usually not enough
in the middle of summer? Because I'm not running adiabatic on my gas cooler. It's just straight air. So by doing that, it's less maintenance that we have to contend with on stuff. So now that's where heat reclaim really becomes important. You have to have that heat reclaim to be able to be 110, 115 degree ambient and still keep your gas cooler from getting out of control, because then flash tank goes up, everything gets weird, high pressure valve starts pinching off, VFDs start backing off, and it's basically the system saying, hey, I'm getting too high a pressure. But if your heat reclaim's running like it's supposed to, you're maintaining that.
I mean, yeah, heat reclaim's like one of the left out.
You could say unsung hero.
Unsung hero.
Yeah.
There you go. Hey,
unsung hero.
With our customer, our first system that's in down there, we measured and quantified what we're doing. So we keep hot water heaters in parallel with the swing tanks, but the swing tanks are getting cooled or getting heated, by the heat recovery system. So we were able to take one of their heater systems and just shut it off completely. And we measured the amount of gas savings that was on propane. And for that customer, it was 41 gallons of propane per day.
Holy shit.
Saved.
Wow, it's a lot.
Yeah. Yeah. So you got the propane savings by shutting off the system, but then you've also got what you put into carbon with the exhaust of the propane, right? For burning that propane. What does that cost? Right. So there's other clients that we work with and run some calculations for right now. I've got some people I talk to that are 41 gallons an hour potential savings for some big.
Wow.
So how much energy savings? Because like I'm thinking though that this, with all the energy that you're saving, like one chiller is basically a zero net sum game, right? I mean, because you're cooling for free. You're using that total heat rejection. You're killing the amount of energy that you're doing on your gas cooler because you're not fucking using it most of the time. And then the amount of propane that they're not burning because of that, and plus that savings, and then the energy that they're going to save because of the, like you said, the emissions. You probably get green credits for that as well, right?
Yeah. Those things are all being. I mean, and it's a before it was looking at a chiller system. It was just, hey, this is my load. This is what I need for a chiller. How much hot water can I get? Well, I'll take whatever I can get, right? So long as I'm not condensing. Now the game's different. Now it's a more holistic approach. Like, okay, I'm a refrigeration chiller guy, and now all of a sudden I'm talking to people about hot water swing tanks. I mean, 2 years ago I wasn't even thinking about that. Now all of a sudden it's just a whole new dynamic when you're looking.
I mean, because you guys are generating that much hot water. It's insane. Like I just working with that CO2 rack the other day that was heating the store, like, and it had no load on it. Like I couldn't believe how hot it got the hot water loop for the boiler hot water loop in like an hour and a half of running. We were up to like 160 degrees with no load on it. With load on it, it probably would have been hitting 200.
Oh yeah. Well, and that's the other thing with CO2, right? As a mechanic, like now where stuff's hot, like you can remember, like you could probably walk up to a 404A system. You can put your hand on a dish. Yeah, I don't advise. It's probably 140 to 160 degrees, but it's not like the word for it. It's not like dangerously hot, right? But now you get around the CO2 system, and as you're getting close to some of these things, like maybe you're leaning in, looking at something, you could feel that heat. Like it's hot. Like it's gonna. Yeah.
I got 2 tattoos on my arm from that.
Yeah.
From CO2 rack. I legit have a nice 7/8 style pipe on one, and then like a nice nice discharge header on the other.
Love
So
it.
you were bitching that you wanted a tattoo. You got 2 already.
Yeah, not the ones I want. Just some burn skin. You smell that, you're like, ooh, that's
Yeah.
gonna hurt later.
That's gonna be bad.
No, I have girly hands now. I go to grab a pot in the wrong way that I used to, and I'm like, oh motherfucker, why is it? Oh, okay, office girl now.
So let's talk over the oil system for a little bit, because like I have a couple questions about this, because I know like we have a ton of problems when we like these racks shut down with the oil mitigation. So how are you guys doing your guys' oil system? Are you guys using OMBs or OMCs, or are you guys using the Danfoss controller to fill oil pots?
It's both. How's that?
Right.
We're using the
All right.
OMCs on the compressors. Those are our regulators for the crankcases. So let me tell you, so we come out of the discharge, we go through our oil separator. Then out of
Pictures.
our oil separator, right? Woo.
Let's see some pictures. Where are the pictures?
I don't have a picture of the oil.
Ah,
So we go through the oil separator. We come out of the oil separator, go through a solenoid valve. The solenoid valve, we set it up on a timer, on a timing relay. And that's what's then feeding into an oil reservoir. The oil reservoir then has its pressure relief goes back to your flash tank, and then out of your oil separator, or excuse me, out of your oil reservoir, you're feeding your 2 oil regulators on your compressors. And then the oil regulators are they're the OMC style regulators on the side of the compressors.
So have you guys had problems with with the actual oil drain solenoid, like just being on a timer and not having a level light, or is that worked out better just using the timer? Because we've had a lot of problems with the oil level lights. We're running transcritical. The oil's violent in there. It starts faking out the light, and the light doesn't see the oil, and it gets picked back up at the separator and taken back out to the gas cooler, and then it's all through the system.
Are you talking a light on like your oil reservoir, like a low oil warning type light?
I wouldn't say a light. I should say it's an optical eye. So
Yeah,
it's an optical eye.
I've got that.
Oh, you do?
Yeah,
So
I've got that.
So the optical eye sees the oil level, and then it pulses the solenoid on to drain it.
No, so I'm not using the optical eye to pulse the valve. I'm running the valve just strictly on a timer. And so when we built that first system, I spent a lot of time dialing in my on and off cycle on that solenoid valve to get it set so that I held my oil reservoir at a pretty stable level, as opposed to having like a
something like that.
No, does that got an actual sensor?
No, so basically this sticks right in. So this can be used for liquid level or oil level.
Okay.
And basically, okay, never mind.
Yeah, this one, ones that I'm talking about, it's just a I think Cryon makes it. It's a Delta. It's not a Delta PT.
I know which one you're talking about.
Yep, I think it's a SE1 or something like that. It's just an optic eye that's looking at a level, and once that, and it's not immersed in the oil at all. Yeah, there's a different insert fitting that goes into that. So
Kevin, you gotta remember with his shit, he's got a constant load all the time. So like
you're varying a lot.
Yeah, so like his oil consumption should be pretty steady while he's in production, right?
That's right. Okay. I don't have huge variations in load.
And he only has 2 evaporators, so if the superheat's straight, he should be fine as far as turn on the suction side, right?
Yeah, and I'm close coupled too, Kevin. Remember that everything's tight and compact. I don't have these long runs and ambient issues that I got to deal with and slopes and all that jazz, right?
I mean, I like the pulsing better on the oil reservoir anyway. Like I would rather drain it more on the oil separator more than the optical eye, because when you're running TC, I mean your oil flow rates increase dramatically on the compressors. They start pumping a lot more oil, even though it's a close coupled system. But like you're still able to make that up a lot faster than we are. But I mean the timer is an awesome idea.
Yeah, I mean, it works really well.
Like a couple times an hour or a couple times every 10 minutes.
No. It's much more than that. 4 seconds, 4 seconds on, 30 seconds off is about where I'm at on my circuit.
So constantly every 30 seconds, it's
constant. Every 30 seconds, it's doing a 4 second open cycle.
You know what? I like that because it's draining every bit of oil out of there that you could, which is what we do on the MT systems, like that started doing down in transcritical, because I mean we had so many problems with the optical eyes catching all the oil.
Gotcha. I built one system, a transcritical booster that used the optic eye for it, but that was one of my custom projects. So we built it, and I don't, shoot, Brett, you may know them, the guys at RSI in California.
Yep.
They fired it up and they work with it, but I haven't really gotten any reports about how well that operates for them. It was specified by them, but it had the optic eye to control the solenoid valve on that one.
Gotcha. There's a new place that's opening up out in Arizona that I'm really, really, well, we'll talk about it when we get off air, but like it's huge freaking facility, and I'm chomping at the bit to get out there.
Oh, nice. How's your system going, by the way? I saw you got your trainer in.
Not yet. It's on order. It's on order.
I saw the picture. I thought that was it.
Nope. I'm waiting. Unfortunately, it takes a while to build because they're redoing the piping on it. I should expect it the end of third quarter. Just so nice. I have it just in time for classes for the fourth quarter. So I'm kind of stoked.
Oh, that's
Kevin, I'm glad you brought it up, because Kevin is just irritated the fact that I won't stop talking about it, because I'm super excited about it.
I can see Kevin rubbing his face as soon as I mentioned it.
I know. Well, usually he looks like the Unabomber. He's in the back there.
Yeah.
The Unabomber.
Fun times.
Oh my God. So anything else you want to talk about, Kev? Was there any other questions you had about his chiller? I want more pictures though. I want to see more pictures.
Photos. I just don't have.
Does that PowerPoint have anything else like inside?
It does. Check it out. Yeah. So let me share my screen. Yeah. Let me show the rest of this. Let's see if I can get this working here again. How's that?
Sorry.
Did that come up for you guys?
Yeah. Yep. We're looking at it.
So this is what this PowerPoint just takes us through. So we don't have the sheet metal on it here, and I might be able to zoom in. So here I'm working with the guys from the facility.
Mm-hmm.
So what we're doing is this is a gentleman. He's with a company, Arctic Refrigeration, up in Anchorage.
Okay.
And they're the service provider. They're the guys taking care of the system. And then the gentleman here to the right, that's the owner of Denali Brewing. It's on. And so we go through a week-long training at our facility, just going over the components, the flow of the system. And then we're down here and they're just identifying each of these components. So here's the oil separator. Let's see if I can get that kind of right in front of him. You can see where my cursor is the blue coil solenoid valve. So we come through, we go through a little filter. It's just a real fine mesh filter screen. Then we go through the solenoid valve. Then we go into the oil reservoir. And my target that I want to keep that oil reservoir at kind of mid-level sight glass. It floats as the system operates, but about 3/4 of the way down the oil reservoir, we do have an optic sensor that'll throw an oil warning light on. And it's not a hard alarm. It's just a soft. It says, hey, your oil's getting a little low inside this reservoir. I'm not sure if I can show.
And I'm sure you have low superheat alarms everywhere on this place, so you don't damage those compressors, because I'm sure those 50 horsepowers aren't fucking cheap.
Oh yeah, absolutely. This was while we were up then. So that was in our manufacturing facility. This is up on the job site in Talkeetna. So we're just going through, getting everything fired up and commissioned, everything getting charged up. There's a good view. Here's a poke. So this guy that's with me here, this is John Vandergiesen. He works for me on the technical team and is one of my technicians. And this kind of my target here with this is what I take the time and set the time aside to be able to kind of make sure he's learning from me and I'm able to pass my information down to him so that he's able to go ahead and do this troubleshooting and commissioning and firing up of the systems. It's not hanging on to all that info. We're charging the system up here. We've got the liquid dip tubes. I'm just running a straight charging hose. It's not a high pressure hose or anything like that from a transcritical gauge. This valve right here in front of him.
Heat reclaim.
Yep, this is our heat reclaim valve right here.
Mm-hmm.
This is the back side of the oil reservoir. This is the bleed line coming off. This goes straight back to the flash tank.
And you said on this one you're maintaining 550 for the flash, and then your suction pressure is what there, Damon?
Suction pressure will run around 350 psi right in there. 22 degrees. Go off of if we're looking at a CO2 chart, 22 degrees is my target suction temperature on that circuit.
So is it usually about like a 10-degree delta you guys are running, or is it a little bit less than that?
Be close. As things dial in, you can tighten it up a little bit. But what I find you end up doing is you might if I'm trying to maintain, like in these guys' case, I'm running 28 degrees, but I'm running a 22, so I'm running a 6-degree split on this system.
Gotcha.
Or the approach.
That's pretty good.
Yeah.
So
then,
do you get this thing out pre-charged, or is it like close, or do you guys blow it down? Because I know you said you run in the facility before it comes out, right?
Correct. So what we do with every system that goes out, we fire it up and run it with fully loaded conditions inside the facility, and then we drain down the CO2 out of the system. It arrives to the job site with a 100 psi nitrogen charge on the system, and that comes out, and then we just pop everything right back in, recharge with new CO2.
Kev, from my understanding, you can't. I think there's some kind of DOT regulation where you can't actually take a piece of equipment that has CO2 in it and transport it, because like we were just toying with this idea the other day just to ship some equipment, and they can't do it, even if it's a higher bar. Yeah,
even if it's higher pressure rated, standstill pressure. Yeah, that would make sense. This was their installation. This is kind of the end of the job site, cleaning everything up and making sure it's in ship shape.
So your TD on your air cooled condenser or gas cooler is what are you guys trying to maintain on that?
If I can. So, well, it depends on if I'm subcritical or transcritical, right? What I'm really controlling everything to is my gas cooler outlet temperature, which I'm looking for around 70 degrees, somewhere in that range.
Oh wait, yeah, because I guess you're able to achieve that because okay, all right.
High pressure valve, right? And the heat recovery. So this gives this is a snapshot I took of one when it was in operation up there. So we were running, discharge temperature was still pretty low at 152. And that's because these guys aren't running the heat recovery system in that picture. So everything's running at lower pressure at that point for them. But it just kind of gives you a snapshot of what the system was doing in operation. You can see the flash tank was up to 580, flash gas valves increasing. And if I was watching this live, I would be expecting that flash gas valve to be opening up, increasing.
So I don't see the 3-way valve on that little diagram.
We didn't put the 3-way valve or the heat exchanger there in that on that scenario. So I guess it would be over here.
No, it's fine. Do you have a P&ID diagram to see the actual piping or no?
I don't have one available readily right now.
Okay, that's fine.
It would bog us down. This is just the crew when we did the startup on that particular system.
Well, next time I'm out in California, how far is that from like LA?
Where this facility is?
Yeah.
About 3 hours north, because you're just past Bakersfield is where it's at.
Damn.
A little too far of a jaunt. Central Valley. Do you have any down in LA? No, nothing in LA, but shoot, go up further up north and you got, well, I mean, I guess you'd have to get to Fresno or Stockton. There's a big CO2, Yosemite Foods is a big project up in there. Coalinga State Prison, that's where that booster system rack is at. But now you're getting over towards the coast and stuff. So,
and you guys manufacture these in North Carolina, right?
Yeah, Mocksville, North Carolina is where the manufacturing facility is. So we're just south of Raleigh and north of Charlotte, kind of right in between Raleigh and Charlotte.
I would go there when I worked for Ingersoll Rand. They have their facility out there.
It's in Moxville.
Oh, it is. No shit.
Yeah.
Okay.
So it's the same town, same little town. Yeah, there's an Ingersoll Rand facility right there. So if you ever make your way out to here, give me a holler and
Yeah, for sure.
drop in.
Stop at a distillery somewhere.
We got about 30 minutes south of us. We got a few big breweries just right around town.
Well, I guess I know where I'm going this summer for training purposes. I'm going to investigate this new CO2 trainer.
That's right. That's right. Get you out here
One
for
in
a
Alaska.
What's that, Ken?
I'd rather go to the one in Alaska.
Yeah.
Alaska sounds much nicer.
I don't like snow. I don't do
Just
snow
go-
anymore.
Go in the summer.
I don't do snow.
Just got mosquitoes as a pterodactyls.
All right. Well, I mean, man, Damon, thanks for coming on. I mean, I didn't know if there was anything else that you wanted to talk about.
No, guys. I mean, yeah. If anybody ever has questions on CO2 chillers or how to get a hold of us, reach out. Prochiller.com is our website. We've got a lot of good resources there. We've got Pro Green is our homepage for the CO2 systems. You can get a lot of technical specs, things like that. Get in touch with our sales team if anyone's looking for quotes, that type of stuff. But don't ever hesitate to reach out, and we'd love to hear from people.
Good deal. And I'm going to plug this, Kevin. I don't care if you're going to get mad at me or whatever. But hey, the North American Sustainable Refrigerant Council is going to be going on in April 4th. Everybody show up because it's free CO2 training. Everyone's going to be there from Kaiser Warren to Gutner, Corel, Phoenix, and Foss. Like they've got all the major manufacturers doing a whole bunch of training for 2.5 days. So I highly recommend you guys going out there. It's in Irwindale, California.
Yeah, that'll be great.
So, all right, guys. Well, man, thanks for listening. Have a great night.
Thanks a lot. See you guys.